Lesson 13-3, probability and area. In this lesson, you learn to find probability using area models. And when are you ever going to use this? Knowing how to relate probability to the area can help you find the probability of a dart landing on a dartboard. So let's take a look at this example. You probably know this game. Have you ever played a popular floor game like this one? If so, then you know that it is easy to get tied up in knots. The spinner shown is used to play the game. It has 16 equally likely outcomes. What is the probability of spinning left hand yellow? Okay, so if you look at this particular board, you want to find out the probability of spinning left hand yellow, which is in this area right there. So there are 16 possible outcomes and one way the event can occur. So therefore, the probability of spinning left hand in yellow will be 1 out of 16. So in lesson 13-1, you learned to relate probability to spinners or number cubes. You can also relate probability to areas of geometric shapes. So if you take a look at this particular area right here, let's say you have a beanbag, and let's say you don't have any skill in throwing in a beanbag, and let's say you're asked to throw the beanbag 50 times. Okay, so what is the probability that the beanbag will probably fall in this square right over here? Okay, so to be able to find the probability of the beanbag falling in this square out of this whole target right here, we can use a formula. So in this case, we use a formula for the number landing in the small square, which is this one, over the number landing in a large square. So the probability of it landing in a small square, okay, will be equal to the ratio, okay, so let me write that. So the probability of it landing in the small square will be equal to the ratio of the number landing in the small square over the number landing in the large square. Or this is the same as the area of the small square over the area of the large square. And let's see how this is done. So let's say I want to throw the beanbag 50 times. Okay? And then when I throw the beanbag 50 times into that target, what is the probability of it landing in that small square? And this is the formula that we need to use. The number landing in the small square will be equal to the area of the small square. Remember what area is. Area is the number of square units. Okay, so in this case, when you talk about area of the small square, the area of the small square is the number of squares in there. So you end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. And the area of the large square would be 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. 6 times 6 is 36. So 66 square units. Okay? So if we make that, that'll be 9 over 36. Or 1/4. So the probability of it landing in the small square will be 1/4 or 0.25 or 25%. Okay, so we have just related probability to area models. Okay, and we will use a similar formula like this to answer probability and area problems. Okay, let's take a look at the first example, not the second example. First example. So the figure shown represents a dartboard. Okay, suppose you threw the dart randomly at the dartboard and it hits the board. Okay. Oh, sorry. Let me go back to that problem about our square right here. Okay. So we're here, and I forgot to mention, so if the beanbag was thrown 50 times and the probability is 1/4, how many times will it land on that small square? So all you need to do is get your probability, which is 1/4, and then get multiplied by 50 times over 1. Okay, So you end up, this is a 2, this is a 25. So you end up with 25 over 2, or 12 and a half, or roughly 13 beanbags will fall or will drop into that small square. Okay, so if you threw the beanbag 50 times, roughly 13 of the beanbags will fall into that small square. Okay, so that's what I forgot to answer. Alright, time to move back to example number 1. Suppose you throw a dart randomly at the board and it hits the board. Find the probability of the dart landing in region C. And suppose you threw the dart 500 times, how many times would you expect it to land in region C? So we will use the same principle that we used in the previous example. So if you notice, we count the number in letter A to be able to find the probability of it landing in region C. Okay, we need to find the area of region C over the area of the entire target. That's what we did in the last example. Area of the small square over the area of the entire target. Okay, so we know that the area of region C is 8 because there are 8 squares. 1, 2, 3, 4, 5, 6, 7, 8 squares out of 16 squares. So it's 8 out of 16, or 1/2. So the probability of it landing in region C would be 1/2. Okay, in letter B, suppose you threw the dart 500 times. How many times would you expect it to land in region C? So let C represent the number of times the dart lands in region C. Okay, when we do that, we simply get use a proportion, C over 500, okay, equal to 1/2, where C represents the number of times the dart lands in region C, and the numerator represents the area of, or the 1 represents the area of region C, and the 2 represents the area of the dartboard. So we get C over 100 equals 1/2. Okay, and we do cross products. Doing cross products, we now have 2C equals 500 times 1. Okay, or 2C equals 500, dividing both sides by 2. End up with C is equal to 250, which means that, okay, out of 500 times, okay, the dart should land in region C about 250 times. Okay, let's take a look at the last example. The last example, at a county fair, a dart is thrown at the dartboard shown. It is equally likely that the dart will land anywhere on the dartboard. Find the probability that a dart will land in the red region. Then tell how likely the event is to happen. So let's say you basically have no skill in throwing darts. Okay, so you throw a dart in a county fair and you want to find the probability, if you are really bad at this, probability of that dart landing in the red region. Okay, so we get the probability of landing in the red region will be the area of the red region, right here, over the area of the entire target, which is this square. Okay, so first we find the area of the red region, which is a circle, and as a circle, we know that the formula for a circle is pi r squared. Okay, and we substitute the values for pi and r, which is 3.14 times 1 times 1. Okay, why? Because the radius is 1. Radius squared is 1 times 1. You end up with around 314 square inches will be the area of your red region. The area of our target is a square, and the area formula for a square is s squared. Okay, substitute the value for s, which is 5. So this becomes now 5 times 5, or 25 square inches. So therefore, the probability of it landing in the red region after we substitute 3.14 and 25 would be equal to 3.14 over 25. Okay, and that's about 3 over 24, or around 1/8. Okay, we use compatible numbers to simplify 3.14 over 25. We're simply estimating. So the probability of landing in the red region is about 1/8, or 12.5%. And according to what we learned in the past in terms of theoretical probability 1/8, the event is not very likely to happen. Okay? And that's how you solve that particular problem. And let's do some examples. But before we do that, the secret word for this lesson is rivalry. The secret word for this lesson is rivalry. Okay? Let's take a look at this as guided practice if you want to follow along. Each figure represents a dartboard. It is equally likely that a dart will land anywhere on the dartboard. Find the probability of randomly throwing dart landing on the shaded region. So number 4 is what we talked about. The formula would be the probability of it landing in the shaded region, okay, will be equal to the area of the shaded region, okay, over the area of the entire target. Okay, so we know that the area of the shaded region is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 square units. Okay, and the area of the entire region is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 25 square units. So the probability of it landing in the shaded region would be 7 over 25. Okay? So going to our next example, what is the probability of it landing in the green shaded region right here? Make it thin line so I can write better. Okay? So again, the probability of it landing in the shaded region will be equal to the area of the shaded region over the area of the entire region or the whole region. Okay, so the area of the shaded region, if you notice, this is a triangle. So area of a triangle formula is 1/2 base times height, right there. So in this case, my base will be 6, my height will be 6, so it's 1/2 times 6 times 6, or simply 13, because 1/2 times, sorry, 18, 1/2 times 6 is 3, 3 times 6 is 18, so this will be 18 square inches. That's the area of my shaded region. Okay, so this is shaded. And the area of my entire region will be the area of this square right here. So my area of my entire region will be S squared, or 12 squared, or 144 square inches. Okay? And we apply the formula, area of the shaded over the area of the entire region. We'll make that in green, and make that small too. So the area of the shaded region, so the probability of landing in the shaded region will be equal to 18 over 144. Okay, and 18 over 144, okay, can be reduced to 1 over 8. Okay, so that's 1 over 8, probability of it landing in the shaded region. Okay, now after finding the probability in number 4 and number 5, we can answer number 6 and number 7. Suppose you threw 150 times at the dartboard in example 4. Okay, how many times would you expect it to land in the shaded region? So in this problem, all you need to do is get 7 over 25 and then multiply it by 150 over 1. So that's 1, and this is 6. 6 times 7 will be 42. So it's around 42 times that it will land in the green region. And now we can also answer number 5. Suppose you threw 150 times the dartboard in exercise 5. What is how many times would it land in the shaded region? So you get 1/8 and multiply it by 150 over 1 again. Okay, and that would be Uh, that would be 2. Divide that by 4. Now with 4 divided, that would be 2. 150 divided by 4 would be 6. 6 over 2. No, that's not right. 150 over 8. Okay, let's do that again. So it's basically just, let me just multiply straight. And do that thing. So that's a 4. That's 75. Okay, so 75 over 4 is around roughly 19 times, about 19 times. So about 19 times it will land in that shaded region. Okay, let's do the example number 8 because it's the one that you're going to have the most difficulty in. So pay attention. A randomly thrown dart. Okay, a randomly thrown dart is thrown at the dartboard shown. It is equally likely that the dart will land anywhere on the dartboard. Find the probability that the dart will land in the shaded region on the figure below. Then tell how likely the event is to happen. So in this case, okay, you want to find the probability of it landing in the shaded region. Okay, and if you notice, to be able to find the area of the shaded region, you need to get the area of the big square minus the area of the small square. So for you to be able to find the probability of it landing in the shaded region, okay, is equal to the area of the shaded region over the area of the entire region. Okay, now it's a little bit tricky because to be able to find the area of the shaded region, you need to find the area of the big square minus the area of the small square. Okay, and we know that the area of the big square is s squared or 8 squared, and the area of the small square is also formula s squared or 2 squared. Okay, applying this, you now have 64 minus 4 or 60 square inches will be the area of your shaded region. Okay, the entire region is simple because the entire region is simply the square, so the entire region is s squared or 8 squared, which is 64. So going back to the formula, the area of our shaded region is 60 square inches, and the area of the entire region is 64 square inches. Okay, and if you simplify this, this will become 15 over 16. At 15 over 16, that's close to 1. This means that the event is, well, actually I erased it. The event is very likely to occur, which is this one right there. There you go. So 15 over 16, the event is very likely to occur. Again, rewind this problem, see how I solved it, okay? Because you will do the same thing for exercise 14, okay, and exercise 12, okay? And that's it. I think I mentioned the secret word. The secret word is Tar Heel. I think that's the one. Okay, thank you for watching.